I am going to discuss work energy theorem. It forms the basis of the chapter work power energy, and not only work power energy but the entire mechanics. In the mechanics problem, we can see the application of work energy theorem almost in most of the problems. So let's understand work energy theorem and how it is derived from Newton's second law. Let's say this is an arbitrary curvilinear trajectory and a particle is traveling with initial velocity v1 and the final velocity is v2. So the point 1 and the final point 2, and during the subsequent motion, suppose the particle is acted upon by many forces. Let's say three forces are acting on this particle: F1, F2. For the sake of simplicity, I am considering three forces acting on this particle. Let's say F1, F2, and F3. So from Newton's law, we can write F1 vector plus F2 vector plus F3 vector is equal to mass times its acceleration. So now, since this trajectory is curvilinear, we can resolve these forces in tangential and the normal component. Let's say F1t plus F2t plus F3t, these are all the tangential component of the force. Tangential component means the the forces along the tangential direction, along the direction of velocity, and this will be nothing but mass times the acceleration, tangential acceleration, that is at. Now we can also write m times at as dv over dt, rate of change of speed, and it is also equal to mass times the rate of change of speed can also be written as dv over ds times ds over dt, and ds by dt is, by the way, v, speed v. M times v dv over ds is equal to f1t plus f2t plus f3t. So now when we multiply by ds both sides, so we get f1t ds plus f2t ds plus f3t ds is equal to mv dv. When we integrate both sides from initial point to final point, from initial point to final point, initial to final, and here mass is constant coming out of integration, so initial speed is v1 and the final speed is v2. Now let's recognize what is this quantity f1t ds integral. Of course, this direction is tangential one, this direction is tangential, so f1t ds can be f1 dot ds, which is the elementary work done by f1. This is f1t ds, and we say this is dw1. So dw1 plus again f2t ds is work done by force 2, which is dw2. This is elementary work done. Similarly, dw3 f3t ds, and integrally from 1 to 2, from 1 to 2, and from 1 to 2, and this is equal to m times v dv. Integral is v square over 2, and if you put the limit here v1 to v2, we get dw1 from 1 to 2 is work done by the first force from point 1 to 2 plus work done by second force plus work done by the third force, all from point 1 to 2 is equal to half m v2 square minus half m v1 square. So we can see that this is nothing but work done by force 1 plus work done by force 2 plus work done by force 3 from point 1 to 2 is equal to change in its kinetic energy. So we can state that work done by all the forces acting on the particle from initial point 1 to final point 2 is equal to change in its kinetic energy, and this is work energy theorem. I hope you understand it, and later we will solve some of the problems using this concept work energy theorem. Thank you very much.